Sodium calcium fluoride is added to pure water so that at equilibrium some solid remains undissolved. So that's basically just telling us that at equilibrium we have both solid and aqueous concentrations. Given that the dissolution precipitation reaction is given by CaF2 goes to calcium ions plus 2 fluorine ions and the solubility product, what is the equilibrium concentration of fluorine ions in the water? Okay, so let's start with kind of what we're given. All right, so we know that the solubility product is going to be equal to Ca2 plus times our fluorine ions squared, right? Because we've got the stoichiometric coefficient here. All right, and remember these are both the equilibrium concentrations. All right, now we're given KSP. We're told that it's 3 times 10 to the negative 11 molarity cubed, but we don't know the calcium ion concentration or the fluorine ion concentration. So we've got one equation with two unknowns. All right, when in doubt, go back to the chemical equation. So we have CaF2 going back and forth with calcium ions, aqueous calcium ions, and 2 fluorine ions. All right, just like our equilibrium example, we're going to use the stoichiometric coefficients to help us determine a relationship between the amount of fluorine produced and the amount of calcium produced. And in this situation, we're just going to go ahead and assume that the water, it didn't have any calcium or fluorine in it, which is a pretty good assumption since we're told it's pure water. In fact, I don't even think that counts as an assumption anymore. Okay, so let's think about this. Maybe we'll draw a picture one more time. Let's say I add 1 mole or 1 molecule of CaF2, and I want that to completely dissolve. So that's going to form some number of calcium ions and some number of fluorine ions. I've got 1 calcium on this side, so I only need 1 calcium on this side. However, I've got 2 calciums on this side, 2 fluorines on this side. So I'm going to need 2 fluorines on this side also, so I'm going to need another one. So if I start with 1 calcium fluoride, I'm going to form 1 calcium ion and 2 fluorine ions. And we could do this pattern a couple more times, but we can also just use the stoichiometric coefficients. I've got a 1 and a 1 in front of calcium fluoride and calcium ions and a 2 in front of fluorine. So what that tells me is that the amount of here I'll do it this way actually, since we're solving for fluorine. The amount of fluorine produced is always going to be twice as much as the amount of calcium ions produced. Okay, so since we start with 0, both of these, the change in concentrations is going to be equal to the final concentration because it's going to be 0 plus whatever equals whatever. And so this gives us a relationship that our fluorine ion concentration is going to be equal to 2 times our calcium ion concentration. Okay, so basically we have one equation here, we have a second equation here, which means we can solve this. Okay, so let's say KSP is equal to, instead of calcium, we're going to solve this equation 2 for fluorine. So that will be 1 calcium is equal to 1/2 fluorine and times another fluorine squared. Okay, so then this is going to be KSP equals 1/2 fluorine cubed. We know KSP, so all we have to do is solve this for fluorine. So the concentration of fluorine is going to be 2 times KSP to the cubed root. And what you should find, ran out of room, so I'll write it over here. This will give you fluorine is exactly equal to 3.9 times 10 to the minus 4 moles. Okay, so not difficult math. The hard part about these problems is just recognizing this first step, the relationship, the stoichiometric relationships between products and reactants.